Let's try that again. Happy Wednesday, everyone, and welcome to today's webinar on an introduction to the Compute Canada Federation. My name is Jennifer Abel, and I am the training coordinator for the Portage network. This is the final webinar in our co-presented series with Global Water Futures. This series aims to educate researchers and data professionals across Canada on research data management best practices and tools that are available to support them. These webinars will help you navigate the evolving RDM landscape as funders, publishers, and the research community increasingly require good RDM practices. And I'd just like to acknowledge at this point that I am speaking to you from the traditional, ancestral, and unceded territory of the Coast Salish peoples, including the territories of the Musqueam, Squamish, and Tsleil-Waututh nations. So our presentation today will introduce you to the Compute Canada Federation and how the National Digital Research Infrastructure helps to support research across all disciplines in Canada, with a particular focus on services for social sciences and humanities researchers. The presenters will discuss briefly about the various services that researchers can access through the CCF and how they're partnering with other organizations such as Portage to support research data management and ensure access to data for all researchers. The presentation will also introduce you to different types of data storage available from CCF, as well as best practices for data management, sharing, and distribution. We'll cover differences between long-term archival data storage and medium-term conventional storage, their limitations, and methods of utilizing their advantages. There will also be a discussion of different methods of data sharing and distribution, concentrating on using the CCF Globus Transfer service. A couple of housekeeping. Get started, you automatically when you entered the room. So if your emergency alert notification goes off during the session, we probably won't hear it. So that's okay, but hopefully you will. This webinar is being recorded and the chat may be archived for those who are unable to attend. We encourage you to use the latest features of the latest version of Zoom so that you have access to all of the features, including security updates. Please use the chat feature if you're having technical difficulties or have additional resources to share. But please use the Q&A option to ask any questions of the presenters. Questions will be addressed at the end. You may also raise your hand if you wish to ask a question. Questions may be asked in English or French. They will be answered in English, so I will be translating them for the presenters. You can find the complete code of conduct that we follow at the web address on your screen or in the chat. Carl and the Portage Network are committed to providing a welcoming, safe, and harassment-free environment for its staff, membership committees, and working groups, as well as for participants, speakers, and organizers of Carl meetings and events. We don't tolerate harassment of any kind. And now, a little bit about our presenters. We have three today. Megan Meredith Lobe is the Digital Humanities and Social Sciences Analyst for UBC's Advanced Research Computing team. In addition, she serves on the Compute Canada Humanities and Social Sciences National Team. Sergei Stepanenko is the Advanced Research Computing Coordinator at the University of Saskatchewan and the WestGrid CCF site lead for the province of Saskatchewan. He is a member of several CCF national teams and the lead of the Globus national team. And Lydia Vermaiden joined AceNet in 2020 as a research consultant specializing in humanities and social sciences. With an MSc in physics and quantum information, her experience spans several research fields, including experimental quantum physics, nursing, psychology, and public health. And if that isn't a wide range, I don't know what is. And now, our presenters, you have the virtual floor.
Okay, can everybody see my screen okay?
Yep, right. Looks good.
Perfect. So welcome to Introduction to the Compute Canada Federation. My name is Lydia Vermaiden, and I'll be doing the first part of this presentation today, talking about what is the Compute Canada Federation and what are the types of resources that we have to offer for researchers across Canada. So Compute Canada is a not-for-profit organization. We're funded through the Canadian Foundation for Innovation, and we are supported through regional partnerships. So I'm out in Atlantic Canada, I'm part of AceNet, and there are several regional consortia that together partner to support the Compute Canada Federation. The Compute Canada Federation is responsible for advanced digital infrastructure nationally to support industry and researchers in Canada. We have approximately 200 staff including world-class experts in computational research and applied in a variety of different fields. As before mentioned, I'm the expert in humanities and social sciences in Atlantic Canada, and we also have many experts across different subject areas such as machine learning, big data, biological sciences, oceanography. As you can imagine, it's broad. This is to ensure that our researchers across Canada are able to access the support they need in their own subject area to perform world-class computational research. We have 4 regional consortia. So as I mentioned, ACENET is in the Atlantic Canada. We have Calcul Quebec and Computer Calcul Ontario, and Westgrid, which makes up the Prairies and BC. So the regional consortia, most but not all of them, host a variety of national systems, but the systems are made available at the national level. So if there is a resource in BC that's hosted in BC that would be best suited to be used by a researcher in Ontario, that service is available to them. So national systems, but regional, a lot of regional staff and support staff and training staff. Megan is going to talk a lot more in detail about the services, supports, and training, and I'm going to focus a bit more on the actual physical resources that we have available. So the supporting research, we focus on 3 main areas. So resources, so this is the physical hardware that we have available for researchers to use. Services that sort of accompany and support use of that hardware, and expertise to go along with it to really assist our researchers in making best use of those resources and good decisions about how to incorporate them in their research. So the physical resources that we have available. We do high performance computing, big data, GPU computing, and storage. These are on our clusters. Cloud environment development space. So this is reasonably recent in the last few years and is continuing to expand and develop and includes storage and outward facing IP address, meaning it can be used to host portals and websites, can be used as shared analysis space in some cases, or for data collection. And what these systems facilitate is data storage and that is stable and secure and is being managed well and backed up. So these national systems, there are 3 multi-purpose or general purpose clusters. So we have Beluga, Cedar, and Graham. And depending on which cluster you're at, different services are available, but they have all CPU, GPU computing, storage, and Graham and Cedar also both have cloud development space. And together they have approximately 130,000 CPU cores, 600 terabytes of RAM, 30 petabytes of disk storage, and 1,600 GPUs. So this is, I believe, the largest heterogeneous computing system in the world. These are shared resources. So we have a scheduler in place to determine who gets to use what when, and in a way that's done equitably as best we can. And we service more than 12,000 user accounts. We also have 2 special purpose clusters, Niagara, which is designed for large parallel jobs if you're into parallel computing. So thinking 1,000 cores up to 60,000 cores, so all working together. And our Buddhist, which is primarily a cloud resource. So again, this is more for persistent web services, portals, hosting online tools. These are the types of technologies that we see a lot in humanities and social sciences. So that's a big part of what I do is working with our Buddhists. So all of these resources are available at the national level. So even though I might be working with researchers in Nova Scotia, they are able to have access to Arbutus, and I'm able to help them with that. I'm going to turn it over to Megan, and she's going to talk a little bit more about services and training.
Thank you so much, Lydia. Can everyone hear me? Thumbs up. I can only see. Okay, great. Thank you for that. So in terms of what Compute Canada does, we've had the hardware, which is really the big boxes with blinky lights and cold rooms. But the other parts of what we like to think of as the digital research infrastructure are the services and the people really that help you utilize those in your research and optimize what you can do. Our main focus is really on helping people do research. So I'll talk a little bit about what the services are and the type of expertise, and also how can you access these things? How can you get in touch with us? How can you take advantage of this excellent platform that's available? So again, this is a list of some of the main services that Compute Canada offers. Training is a big one, and I'll go into a little bit more detail about that in the next slide. Centralized software, which is great. There are tons of software. I think we have, let me find my link to, if I have a link to the available software on Compute Canada. I'll find that. So there is a huge amount of software already available on the system. If you have your own things you want to bring to the system, your own software, we can help you put that on as well. So the software is available for researchers, a lot of it very specialized, and there is tons of it. Nextcloud, this is something that's, it's sort of a small Dropbox like service, which has been very helpful, I find, for the humanities and social sciences crowd. It is like Dropbox. You get sort of 50 gigabytes of Dropbox-like cloud storage. It's hosted in British Columbia, so it's in Canada if you have any need to keep your data in Canada. It's very useful for people who are not as technically inclined, and so something like being confronted with a command line is not something that you like. Nextcloud is a great little tool for sharing some data. I've helped a lot of social scientists doing projects on actually community water resources, come to think of it, use Nextcloud in their field work, where they go collect some data, upload little bits of it, somebody on campus will take it down and use it again. Specialized data portals. So these are things like Jupyter Hub, available through Compute Canada, and also GenApp for people who are working with genetic data sets. Those are available. One of the big collaborations is the Federated Data Repository, FDR, which is a collaboration, of course, between Portage and the Canadian Association of Research Librarians. It's hosted by Compute Canada. And this is it's a data repository that allows researchers to ingest, curate, and discover and share data sets. And also it pulls in repositories and data from other institutions, so you can have access to data across the country. And finally, the Globus file transfer, which I know Sergey is going to talk a lot more about, which is a very important component of the research data management ecosystem, of which Compute Canada is a very important part. Can I have the next slide, Lydia? So yeah, I wanted to talk a bit more about our training offers, because this is one of the most important things we do. Is we have our big digital research infrastructure, our big boxes and our software and everything, but there's also a concerted effort amongst all the different regional consortia to help train researchers across all disciplines, across the entire country, to be able to use these resources, to take advantage of them, because they are there for you. So some of the types of things, some of the types of trainings we offer, discipline-specific training. Compute Canada has been involved with the Digital Humanities Summer Institute for a number of years. We have in the chat, we've put up links to the training offers of the different regional consortia, so you can get an idea of what's offered in your region. So the discipline-specific training, we work with Digital Humanities Summer Institute, teaching a number of courses at that event in the summer, again, focused on digital humanities. But with the disciplinary support we have across Canada for things like bioinformatics, subatomic physics, you name it, there is training available, pardon me, for anybody really who has a group of people who want to learn how to optimize their use of Compute Canada in their discipline. We also offer software carpentry training, and this is part of the carpentries group, so things like data carpentry, software carpentry, high performance compute, lots of carpentry. And those are courses that we offer, and these are excellent if you're not familiar with them, excellent sort of 1-2 day long sort of boot camps to get you going, basic command line, Python, using Git and GitHub for version control, things like that, just to really get you started on not only using some of the computational tools that you can take advantage of, but being able to start thinking computationally about, how do I ask a computer question that can actually help me with my research? And so these kinds of training opportunities, especially with the software carpentry, can really get you going on that. Again, a lot of different training through the regional consortia. And again, the links are there. There are a number of different summer schools. I believe a number of the consortia are offering fall training classes as well. One of the advantages that Compute Canada has sort of always had is we've always been a very national distributed virtual team. So starting to live our lives on Zoom is kind of how we've always operated. And the new Zoom world has actually allowed our training opportunities to really thrive, I think, because more people are able to access the training and more people are able to attend these courses. So wherever you are in the country, you can have a look at what the main regional hub, Westgrade if you're in the West, AceNet and Atlantic Canada and in between, to see what they're doing, to see what training is available, to see if any of it's useful. Reach out to the people there to say, I have a group of people working on this, interested in this research question. Is there anybody who can come teach us, give us a workshop on something? So reach out for sure about that. Attend the summer schools, attend the fall training sessions. There are courses of these which range from very beginner introductory courses all the way through to quite advanced. So there's a broad range of skills, etc. Lydia and I will be hosting a humanities and social sciences focused training session in the new year as well. And so they kind of go on through the year. I think I'm ready for the next slide. So the last sort of broad category of support that Compute Canada has is the expertise. So that's the people, the 200 staff that work for Compute Canada who have an incredible amount of knowledge, not just about how computation works, how to work a big machine, but also really deep experience in research and making that vital connection between what you want to know and how the infrastructure can help you answer that question. And that's a real vital connection. And the expertise in Compute Canada is fantastic for making those connections. So some of the things that we do, consultation. So what sort of resources do you need? This is what I want to do. Do I need 12,000 cores to run my job, to answer the questions? And we can help with that. What sort of computational resources, what infrastructure do you need in order to answer your research questions. Designing, optimizing, troubleshooting code. We have a number of people who can help you make sure that if there's something wrong with your code, we can have a look and help out with that. Customizing tools. If you're using a particular tool, it's not working on our infrastructure for whatever reason, we can sit down and talk it out, help. Support is always available through our support email. And also I'll go into some more detail about how you the best ways to reach out to find people to talk to. Specialized support is available for a range of disciplines. There are, for humanities and social sciences, for instance, there are 3 experts in Compute Canada located across the country. So myself, I'm at UBC, Lydia is at St. FX. There's also John Simpson, who's at the University of Alberta. So 3, and we all come from very, very different areas. I'm an archaeologist, John's a philosopher, Lydia does everything else, I think. So there's a very broad range of experience within just the 3 of us. So between the 3 of us, we can certainly help you find the solution to your problem. There are also, again, bioinformatics, subatomic physics. There are chemists all over the place, astronomers. We have a huge range of support, discipline-specific support available. Visualization specialist. There's a visualization specialist. He's with Westgrid. He runs a number of training courses every year. There's also a visualization competition that runs every year where you can bring your data and get help on doing some cool visualizations for it. So again, look through Westgrid, it's fantastic. Cybersecurity, very, very important. There's a cybersecurity support available through Compute Canada. How do I keep my data safe? What do I need to think about when I'm thinking about keeping my data safe? There's privacy as well, and we can really help with all aspects of the sort of what you'd call the research data lifecycle. Let's see, next slide. So again, the humanities and social sciences support. There are a lot of you in social sciences specifically. So again, we have 2 people in Westgrid, 1 in AceNet. There is a National Humanities and Social Sciences, a whole team that Lydia and I work closely with expertise, not just in humanities and social sciences, but across every discipline you can imagine, and really heavy technical expertise too. And they're located from Victoria to Newfoundland. We're across the country. So you can always reach out to the National Humanities and Social Sciences team specifically for more of that targeted advice. Again, HSS targeted training courses, software and data carpentry. There are some specializations for humanities that have been offered within those. And also the courses that are offered at Digital Humanities Summer Institute. Next slide. Okay, so how do you access these great things? What are the sort of entry points for resources, services, and expertise? So I have the, of course, the Compute Canada website. Visit that. You can email support at Compute Canada as well. Just the sort of the main entry points. So the main entry points for our resources, for the hardware, if you already know what you want to do and you just want to say, how can I start using this stuff? So visit ComputeCanada.ca to get advice on how to get a Compute Canada account. These are free. They're available to Canadian faculty, and that includes librarians as well. Once you have a Compute Canada account, you can then sponsor your students, your collaborators, whether they're in Canada or elsewhere. You can sponsor the people in your lab. But again, those accounts are for faculty members. And once you have an account, then you have automatic access. That I'm about to hit you with a lot of R's here. apologies for that. There are a lot of R's. So we have a number of different ways of accessing those. So there's the resource rapid access service, and that is just getting access to some compute right now as soon as you get your account. This is great if you don't have a lot of data, you don't have big jobs, you just want to try it out. And I would encourage everyone to get an account to try it out. We also have yearly resource allocation competitions, RAC, more R's, if you need access to larger amounts of resources. So there's the RRG, which are for bigger, more traditional HPC type jobs. There's also the RPP, research platforms and portals. That would look something more like a large website servicing a lot of data to a larger community, for instance. And the thank you so much, everyone, for keeping up with the links in the chat. And there's a lot more information about these, how these competitions work. And then I would encourage you, if you're curious about applying for any of this, to reach out to one of the Compute Canada experts. For our services, how do you learn about what types of software is available? These data portals. So the Compute Canada Federation Wiki is awesome. You just Google the Compute Canada Federation Wiki, or it's right, hopefully in the chat if I remember to include it. And it's great. It has so much information about absolutely everything we do, and the real technical information of the nuts and bolts of how to get started. It includes the information about the disciplinary support, the software available, and how to use your own software. And then also some information about special support. So Compute Canada is offering specialized support right now to people doing research on COVID, for instance. And then finally, the expertise. Well, you can email Lydia or Sergey or myself at any time. We're very happy to chat. You can also visit the consortia websites for wherever you're located. And there you can find who are the people, who's doing what that looks interesting. They're great sources of information for how to get help at your local institution. That's one of the great things about Compute Canada is it's national. You can access every bit of Compute Canada across the whole country, but we also have people everywhere. So you can always be certain to find someone with institutional knowledge where you are to help you out locally. Visit the wiki pages for the disciplinary support groups. That's on the wiki I mentioned earlier, and attend training courses. There's a lot to learn. They're excellent courses, incredible instructors across Compute Canada. And if there's something you're particularly interested in, an aspect of a particular, your group is using this particular software package and you want to know how to run it on Compute Canada infrastructure, reach out. Somebody in Compute Canada will probably know the answer, and be able to come and chat with your group about that as well. And next, I think that's all for me. Yes, so I'm going to hand off to my colleague Sergey now, who will finish up with the nuts and bolts about the research data management that you're all most excited to hear about. So thank you very much.
Hello, everybody. My name is Sergey Stepanenko, and I will try to give you a short introduction and best practices for research data management and utilization of resources that Compute Canada has to offer, and attempt to answer any follow-up questions. So by now you're already familiar with, from this presentation, what resources and services Compute Canada Federation has. All those resources and services dedicated to achieve pretty simple goal, to get research data and find important information from it. So achieving this simple task is not that simple. We all participating in very complex activity that called advanced research computing. And both users and providers, as Compute Canada, participate in this activity and create rules and practices as they go along. There's no standards that exist for many generations. There's no unified practices that work for everyone. In each particular case, for each discipline, for each research project, there's a new set of challenges, new set of rules, and new set of solutions. I'd like to offer some recommended practices based on long practical experience. By no means these advices are all-encompassing or self-sufficient, but they can serve as foundation for enjoyable and successful computing. Next slide, please. So in computational research, we generate data much faster than we can keep track of it. We also need reliable way to preserve and maintain the data that hard to reproduce and data that require our future research needs. So if we just react to ever-changing and growing volume of data that we possess, eventually we fail and we lose control over what we have, where we have it, and in what state our data. Planning for data management starts way before we have any data to manage. What type of data are being used? How much data there will be in a month, in a year, in a lifetime of the project? Who produces data? Who needs access to data? How data are being processed and analyzed? Not all of it is known, and at the very beginning, and that fact that we don't know ahead of time must be part of the planning. So well-engineered solutions, as we all know, appear very simple to use, while being, in fact, very complex and sophisticated internally. So well-designed rules and practices similarly should appear very intuitive and easy to use. So minimum effort is needed to follow and maintain them by all involved in data-driven research. Instead of setting restrictions and limitations and punitive policies, we must develop policies and practices that can be sustained without harsh enforcement. So almost all tasks applied to data are affected directly by volume of data being managed. What seems to be a trivial task with your personal data on your personal computer becomes much, much more complicated as we start managing group data, and it becomes effectively impossible to manage large volumes of data applying the same rules as we apply to our own small data sets. So conversion of data from one format to another, data compressions, creation of hierarchical structures for data ownership and data access control are progressively more difficult with larger data sets. Eventually, it is practically not feasible to apply some activities to large volume of data because they either never finish in time or they will produce unpredictable outcome. That is why we should employ standards and scalable methods for these activities, which allow us to manage data with the same amount of effort, no matter what size of data set we manage. For example, before we start accumulating data, we need to agree on data formats. And while data formats agreed upon, you don't have to change them along the way. access for data should be based on conditions and methods that are external to the data itself. So therefore, if we need to change or modify policies and practices to access to data, it should not use any attributes that contained within data itself. So logistics of data movement between different locations where data might be processed or accumulated or analyzed is similar to managing transportation flows. Individually, we might not see any complexity in its entirety of the data management, but we all contribute a little bit of disturbance to other activities. What seems to be a trivial task for an individual becomes more complicated for a group and extremely challenging for a large project. This is caused by our individual activities that are not being well organized or synchronized with each other. It causes resources to be overused, like communication lines, storage, computational resources, and efficiency of those resources is reduced. So we cannot avoid this effect completely, but we can minimize it by limiting unnecessary data traffic. I would not recommend to make copies for the means of allowing access to different portions of the data sets you own. Do not move data unless absolutely necessary for a long-term purpose. Keep data directly accessible by applications with the heaviest use of data. In other words, if you are going to process data in its entirety, it should be done where the data lives at rest. But if you decide to move data, use the most appropriate instruments for that task. So Globus would be one of the tools that allow efficiently move large amount of data from point to point. So that's briefly my portion of this introduction, and I would be happy to answer any question you have. Thank you.
Great, thank you very much, everyone. So I will start off with a question. I know there are a number of people on the call today who are specializing in water resources, in hydrology, in atmospheric sciences, etc. Are there any specialists within Compute Canada working in those areas who they should or could be getting in touch with?
Sergey, do you want to?
Yes, I would try to answer. So unfortunately, we do not have a publicly available catalog of experts from Compute Canada Federation support teams. So first stop on searching for expertise in specific discipline would be reaching out to your local Compute Canada or Advanced Research Computing support personnel. So as it was said before, almost every Canadian institution has representatives of Compute Canada Federation on staff, or representatives of Advanced Research Computing support on staff. So these people would be your first step to find out expertise needed. And then within our network, we always can find people specializing in not only in a certain discipline, but in certain methods within discipline, and experts in specific software packages required in that discipline. I don't have names or contact information from the top of my head, but I know how to find it. So if you need, you can reach me directly.
Great. Thank you, Sergey. I'm sure that there'll be a lot of people taking you up on that. A question from Kareem. Do you offer S3 compatible object storage or other type of storage that can be used to store research data being collected for up to 10 years? If so, can we access it from outside like you would use an Amazon S3 bucket?
I feel that this question for me. So let me unfold this question. So Compute Canada Federation, as it stands right now, has no definition of long-term data storage and preservation. We have a definition of long-term only within a certain time frame that Compute Canada defines as operational cycle. And at this time, our operational cycle ends in 2022. So I would say we cannot talk about long-term data storage and preservation in generic terms. We can only talk about within specific time frame. On the other hand, commercial providers like Amazon that provide long-term data storage operate in very generic terms of long-term, which is written in their contract and provided as a service which you pay for. So therefore, there's a difference between services provided by Compute Canada, which are free and subject to specific conditions of funding, and services provided by, let's say, Amazon, that is not free and provided based on funding received from the client base. If we agree on this caveats, then I can answer whether Compute Canada provides or can provide S3 type method of accessing data as objects, similarly to Amazon storage. It is currently being looked at and seriously considered to be implemented within next year to provide access to cloud storage using S3 protocol based on Globus. So if we do have type of storage that compatible with S3 in Compute Canada, then we will provide access to such storage through S3 mechanism based on Globus service. So that's the answer to your question.
Great, thank you. Now, I'm glad someone asked this question because I had it myself. So Isaac, thank you for raising this. Can Compute Canada be used for research data containing sensitive information?
Now, if we break down sensitive information in different types of sensitive information, we will find that each type has its own set of recommended practices, and some of them regulated, some of them are not regulated. And in general, policies and practices associated with sensitive data management are defined and enforced on the end of the data owner. So, for example, if I have a sensitive data and I'd like to host this data somewhere, I operate under policies and regulations of my home institution, which will inform requirements for my storage provider. Storage providers, by definition, and Compute Canada in this particular case would act as a storage provider, do not enforce its own policies and regulations, rather than provide platform that's suitable for requirements of the data owner. So having said that, you can understand that some generic terms for sensitive data storage would require, for example, authenticated verified access, which Compute Canada can provide. Other requirement would be encrypted data storage and transfer, which in principle Compute Canada can support, but it is responsibility of parties involved in accessing and transferring data to encrypt data at rest and encrypt data during the transfer. We do not enforce it, but we support it. Other requirements could be much more difficult to accommodate on shared infrastructure. For example, some sensitive data requirements stipulate that data should be hosted by equipment located in very specialized designated areas with a specially controlled access, with some communication restrictions and tracking of data access for a long period of time. Those requirements are not by default provided by Compute Canada. In situations like this, further consultation with Compute Canada Federation experts would be required for assessment whether those requirements can be met or not.
Great, thank you. Just picking up on something that you mentioned earlier that people might be wondering about. You mentioned that Compute Canada is currently working on an operating agreement through 2022. Is it expected that this will be, Compute Canada will be around for the long term?
Compute Canada Federation transitions into new organization that the name of this organization is still to be finalized, but for the time being, it's called NDRIO, New Digital Research Infrastructure Organization. So Compute Canada is transitioning into NDRIO in 2022, which is, from perspective of federal government, is required transition because new organization will have different focus on providing services to Canadian researchers compared to Compute Canada. Being strictly infrastructure and service provider, Compute Canada has limited scope of responsibilities as research data management service provider and preservation service, where NGO will have these tasks embedded with their mandate for Canadian researchers. So I think in general, transition of Compute Canada into NGO is a good thing, but as any changes, it will bring some uncertainty, some process that would require a change of operations from us and change of services from our users. But we're pretty confident that this transition will be smooth and well organized.
Great. And I think we've got a follow-up question on that from one of our attendees. Will data which is hosted on FERDR or Compute Canada need to be rehomed by researchers before 2022?
No.
No, okay, good. Good to know.
With the caveat, if you don't have resource allocation during that period and you cannot get any longer resource allocation for storage,
right,
you will have to rehome your data regardless whether we transitioning to NDRIO or not.
Great. And a question from Krisha. Does the next cloud solution that's like Dropbox allow for access by people outside of academia so data can be shared with external stakeholders? Would they require a CC login?
I never used Nextcloud, so
You know, I need to look actually. Give me a second to remember that, because I have not used it in a while. I think the answer is no.
If you did require a Compute Canada account, you can sponsor people who are part of your research team, who may not have a position at the university but are part of your team. You can sponsor them through your Compute Canada account if you are a faculty member.
Great.
So anyone can, yes, I do believe you need Compute Canada, but you can sponsor, and you can sponsor people from outside of academia.
Great, thank you. Are there any other questions that people would like to ask while we're all here on the line before we potentially get cut off by emergency preparedness alerts? Okay, well, I'm not seeing any further questions at this point, but I will note that I will be sending around a link to the slides, a link to the video of this webinar, and a link to our survey. Oh, we have one more question. Sorry. Is all the software in Compute Canada accessible for all users?
Yes.
Yes.
correction. All non-licensed software are accessible by all users.
Yes.
Any licensed software accessible by license holders on special set of arrangements.
Okay, so non-licensed software available to everyone. Licensed software requires licensing, license holders.
Yes.
And do you have our software accessible?
Our software, well, our package is open source software, and I believe we have up to the current release of R for Linux available through Compute Canada software stack on every system.
Great.
We also do a lot of training in R through data carpentries.
Great. Okay, so I will point out that when I send out this information, I will be copying our presenters today. So if you have any questions you'd like to ask them directly, you can certainly do that. And I would very much like to thank all of our presenters today, Lydia and Megan and Sergey. Thank you for this great overview. And thank you all for coming. We hope we'll see you next week at our last webinar of 2020, which is going to be about building research data management across an institution. And Megan will in fact be back with us for that. And hopefully a number of you will be back with us as well. So have a great rest of your Wednesday. And we're getting close to the end of 2020, folks. It's going to be getting better soon, I promise. Maybe I won't promise that. I hope.